Research Fellow at Alexandra Hospital. She has expertise spanning both quantitative and qualitative methodologies. She's led multiple systematic reviews, evaluations, and applied research projects, and her passion lies in exploring how virtual care, artificial intelligence, and wearable technologies can transform healthcare delivery and improve outcomes. We're really excited that Jennifer joined our team a few months ago, and that we can all benefit from her, the wealth of her expertise in evidence synthesis. And she very kindly agreed to give an overview of AI for systematic reviews. And we're very much looking forward to hearing this introductory approach to or perspective on the opportunities that AI generates for evidence synthesis. Over to you, Jennifer.
Thank you very much, Chima. So my name's Jennifer. I'm very happy to be here today, and thanks for you all to turn up in person, and for everyone online also listening in. I'll just apologize if my voice gives out a little bit. I'm just getting over a cold, so hopefully I make it to the end. But just apologies on that. So today I'm going to be giving a little bit of an overview, a little bit of an introduction on some of the AI tools that are coming out to assist with systematic reviews. It's definitely an introductory level, but hopefully you go away with some interesting pointers and tips. So in terms of the agenda, first of all, I give a very, very brief overview as to what AI is and what a systematic review is, just to get us started. Then I'm going to go into some of the AI applications at the various stages of the systematic review process. And at the end, I'll conclude with some other resources that might be useful for you on your journey. So starting out with AI. AI is a very, very broad term, and everyone's getting very familiar with it because it's being thrown around here, there, and everywhere at the moment. There's many different types of subcategories of AI. We have machine learning, which is focused more on prediction and decision making. Often machine learning is used in screening tools and systematic reviews. A subset of that is deep learning AI, and that's usually used more in complex pattern recognition, maybe a little less in some of the AI tools that I'm showing you today. And then right at the bottom, we've got our large language models, so our ChatGPTs, our Claudes, et cetera, and these can be used in various different steps of a systematic review process. And then linked to that, we've also got this subset called natural language processing. And again, some of those, this technology is used in various steps in the systematic review process. Okay, so what is a systematic review? Hopefully most of you are familiar with a systematic review, but we'll just go through the basics to start with. So according to Cochrane, systematic review is an attempt to collate all the empirical evidence according to a pre-specified eligibility checklist to answer a specific research question. And it should be using explicit methods with a view to minimizing bias. So that's the Cochrane definition. Now, a systematic review goes through many well-defined steps, which I'm sure most of you are familiar with. First of all, you have to define your research question. And you're usually pre-registering a protocol on a database such as Prospero. So that's the first important step. Then you're going to be conducting a comprehensive search strategy in various databases according to your topic. You're then going through a screening phase where you have a set of eligibility criteria to decide whether you're going to include or exclude your articles that you've found in your search. And then we go through data extraction and finally a quality assessment stage and the data synthesis. So for this talk, I'm mostly going to be focusing on the first 4 steps, not the data analysis stage. And we're going to start off with a very, very simple application before we get into some more sort of interesting nitty-gritties with AI. So research questions for a systematic review. Normally, we would use a framework to help design, structure our research question. And the classic one in systematic reviews is PCOS. So it consists of these various domains: our population or group of interest, our intervention or exposure. Sometimes we're interested in a comparator group, but it's not always applicable. We'll be looking at various different outcomes, whether that be clinical metrics, implementation, patient experience, could be many different types of outcomes that you look at. And then you select your study design. So we're interested in experimental designs like RCTs, observational studies, qualitative studies. But you would use this framework to structure your research question. So let's start with a really simple example of how AI can help with a research question. So this is a really terrible, very obviously bad research question. You can very quickly see it doesn't really address the various points in our PCOS framework. And traditionally, you kind of go through various stages of iteration to try and make it more specific. Maybe you'd be discussing with colleagues. Today, we can very quickly pop this into a LLM, and it will very, very quickly give us feedback on how the research question is bad and how we can make it more precise. So straight away, this is already speeding up this aspect of our systematic review process, refining that research question, tightening it up for us. If you didn't want to use an LLM, there's also products out there now, various pieces of software that can also help us develop our research questions. So I give one example here. It's a software called Elicit. If you drop your question into this particular software, it straight away will assess the research question and give you feedback on it. So again, it's talking about issues with precision with the question, and then it's making suggestions on how we could improve it. So just by clicking on one of these boxes that it suggested, it can iterate and help you improve that research question. So straight away, we can see that AI is helping with our first step in our systematic review process. And it's a really simple example. We'll move on to something a little bit more in depth in a bit. So just some key takeaways on the research question. Although it is great for iteration and refinement, as you can see, super quick, super easy, you have to remember that these tools do lack domain-specific knowledge. So you still have to be very critical, very thoughtful about what your purpose of your review is, what the essence of it is. It's quite possible that these tools will miss some of those contextual subtleties that you may be aware of. So you have to keep that in mind. We also have to be aware that although it's very quick at coming up with suggestions, maybe the suggestions are quite superficial. They might not be relevant. They might not be feasible research questions. So do keep this in mind when you're iterating. Other issues such as hallucination and bias have also been very well reported with things like LLMs. So again, keep it in mind. And then over-reliance is an issue with LLMs for sure. You're not using your critical judgment. You're relying too much on these software. So just keep this in mind if you do use these tools to help with your research question development. Okay, so moving on to something a little bit more meaty, our search strategy. It's the next important thing you need to develop in your systematic review. When we're conducting a systematic review, we're normally looking in various different databases. It's not just a quick PubMed search. We're looking in very specific medical databases, and these are the classic ones that most of you should all be familiar with. They all have slightly different focus. They all have slightly different setup and format, and we'll go into some of that next. When we're developing our search strategy, when we're searching in these databases, we need to do two things. We need to collect our mesh terms or the equivalent, depending on what database you're searching in. And a mesh term is basically a standardized nomenclature used by that particular database to index the articles. So it's mesh for Medline and PubMed. In the other databases, they have equivalent, but just so you're aware. The other collection of terms you need to identify as your keywords. And these are article labels that are usually assigned by the author. And that means they're not standardized. So you might be wondering, okay, so why do we need to look for keywords at all when we can just use this nice standardized terminology with mesh terms? problem with mesh terms is they take time to apply to the articles. So there's a slight delay in those newer publications having the mesh terms applied. And it also takes time for new mesh terms to be developed. So there might be emergent phrases coming out that don't have a mesh term yet, in which case we need to still look at these keywords. So you want to use a combination of both when you're doing your search strategy. And this is just to show you an example. If you're looking for your mesh terms, normally you'd go to the mesh browser for Medline, you type in your term and it should find the nearest related mesh term. And then it will come up with a page that looks a bit like this. You've got your mesh heading, it gives you a definition, when the mesh term was created, et cetera, et cetera. And then on some of these other tabs, for instance, if we go into this one, the mesh tree structures, there'll be a series of subterms that also sit underneath this top header as well. So you can choose to be very narrow with your mesh terms, or you can even explode them and look at all these subterms underneath them. And then your keywords, you can normally find them at the bottom of the abstract in most papers. So that's where we normally find these terms. So, okay, so now, so we've got the different databases, which are set up slightly differently. We need to find our mesh terms and our keywords. The next thing you need to do once you've identified your keywords is you need to think about the syntax for your search strategy. So it's not as simple as just putting in a keyword. You have to think about how these terms are spelt. And there are different things that you need to factor in. And I'll just run you through an example here. So this term is a schemic heart. But there could be many different ways that this particular term is spelt. Maybe there's words in between ischemic and heart. Maybe the words are in different orders. And there's different things you can do to make sure that you capture all the different variations for each of your keywords. The first thing you might want to factor in is your wildcards. So these normally replace okay. Another feature when you're searching in these databases is truncation. So this will help you capture different versions of this word. So maybe it's ischemic, maybe it's ischemia. It's going to help you capture all those different versions rather than you having to type them all out manually. And then adjacency terms. So adjacency is when you've got more than 2 words next to each other and you want them to be within a certain distance of one another. So adjacency free would mean that this word and this word would have to be within 3 words of one another when you're searching. So there's quite a lot of complexity, as you can start to see when you're developing your search strategy for a systematic review. Lots of things that you need to factor in. We've also got our Boolean operators, which I didn't mention there, our and, ors, and nots. So how are you going to combine all your keywords and your mesh terms together? So there's lots of different things that you need to think about. So you might be thinking, okay, so why can't we just put a prompt into ChatGPT and it can just churn all this stuff out for us? We don't need to think about all these fancy adjacency terms, wildcards, etc., etc. And you can definitely use ChatGPT as a starting point, but there are some caveats, I would say. We still need to think about the relevance of the terms that ChatGPT or equivalent LLMs are churning out in terms of how comprehensive they are it might be missing domain specific terms that you're very familiar with and it's not so familiar with. Sometimes it's inaccurate, so you have to be a little bit mindful of that. When it's been evaluated versus a human delivered search, what we're tending to find in the literature is that humans are actually doing a much better job of creating a more precise search strategy than an LLM can do. So that means that if you went with an LLM search, you'd be screening a lot more articles versus a human developed search. The other concluding point is, although these evaluations are based on sort of the freely available LLMs like ChatGPT, Claude, etc., if you have a trained model, they do tend to perform slightly better. They're not as freely available. So just to give you a few tips on how you could use LLMs just to create a more refined search strategy. Make sure you tell it what database you're searching in. Each one of those databases I showed you at the start has a different way of using that syntax. They have different symbols that they use, different functions. So you need to tell it what database you're searching in so it can develop a search strategy that's specific to the database. If you want to apply filters to your keywords, i.e. where it's searching for those terms in your document, you need to tell it. And you need to have some awareness of what all those different filters are and what they are for each database. So you need a little bit of domain knowledge there. We also need to tell it whether we want to be narrow with our mesh terms or we want to explode. So when I say explode, it's looking at all those subheaders as well, or whether you want to focus in on one particular term. So you need to tell it that. And then if you want it to use our truncation, our wildcards, you also need to prompt it. So you need to be very specific if you want to use an LLM, and this will help you, but it's not going to entirely replace the human element. So what else can we do? Well, another option is to use a piece of software, and I've given 4 examples here. They're all quite good at running search strategies. They're all paid for options, so that is a limitation, and they work a little bit differently to what I've just shown you. So I've given you an example of developing a search strategy from scratch. These work by you just entering in your research question, and then it will use natural language processing to find papers that have similar meaning. So it's not searching for exact words, it's looking for similar, what it thinks are similar related articles. These pieces of software also are a little bit more limited in terms of where they search. They'll tend to look in open access sources. So Semantic Scholar is a common one in most of these. And then just to give you a screenshot to see if you're not familiar what the output looks like from these. So you enter in your question on consensus, it actually gives you a nice summary. It's answering this particular question. So 83% of the articles are agreeing that cardiac rehab improves quality of life. So that's a very quick summary, gives you some text, and then it will give you all the articles it identified below. And then another example here is SkySpace. So again, it's kind of similar. It's giving you a nice summary of the articles that it's identified, and it lists the articles down below, so you can look at the resources. So quite useful tools. However, there's no transparency in that search process because it's not searching the literature in the same way as you would do with a traditional search strategy. So we can't reproduce that output. The sources are also limited. They're not looking in those databases that I showed you earlier. And research is showing that there are some sensitivity and specificity issues with these particular tools. And again, we've got issues with bias and inaccuracy in the output. So I would say, although these are very useful tools, and they might claim to be able to do a systematic review search for you, I think there are still limitations with them. And really, they're more useful for scoping at the start of your review. Maybe you want to identify key papers, or just when you're starting out, developing a research question, etc., etc. So we can't replace humans yet, but they're good supplements. Okay, so on to the screening phase of our systematic review. So screening, put simply, it's basically deciding whether an identified article that you've got from your search strategy should be included or excluded according to some sort of predefined eligibility criteria that you've come up with. It's a very, very time-consuming part of systematic reviews. So how can AI help? Okay, so there are lots of tools out there. This certainly isn't all of them, but just to give you some of the more common examples that have AI features inbuilt into them that help with screening in different ways. The three common approaches I'm just going to run you through is text highlighting, ranking, and classifiers. So in a lot of these tools, they will use AI or non-AI means to highlight segments of text that they think are relevant to your eligibility criteria. So it can definitely aid in that screening process. You can quickly kind of zone in on those sections of the text that are most pertinent to your eligibility criteria. Most of them have very nice sort of platforms, very easy to click your screening decision, very easy for you to track how many articles have been screened or what's left to do. So that's the text highlighting features that you see in a lot of them. In terms of ranking, this is where these softwares are able to order the identified articles by the most relevant ones first. So when you're screening, it's showing you the ones that it thinks are the includes, and then slowly down to your excludes. And it does this through two means. It's either through machine learning, so it makes those order decisions based on your screening decision, so it will keep iterating as you go, or it's based right from the research prompt at the start using NLP. So why is that helpful? Why is that helpful to order your papers? Well, it means you're going to identify those most relevant articles right at the start quickly, if it's done correctly. And it might also give you the possibility to drop to a single screener later down, once you're starting to get into it, what it thinks is that exclude list. So you could save some manpower, actually, with this ranking approach. That being said, you still have to be a little bit careful because these systems are not totally infallible. There may be inaccuracy in that ranking. Maybe because you've assumed all the includes at the start, people lose focus towards the end, and then you start to miss things. So there's over-reliance issues as well, but generally quite a useful feature. The other AI approach that's used by many of these tools is something called classifiers. Classifier, you can think of it as a filter, but it's applying to your hits. And it's a filter that's determining whether that article is an include or exclude for you. It works very well on very well characterized things. So the classic example is whether it's an RCT design or it's a non-RCT design. And classifiers are so established that Cochrane even have their own software that uses this approach, although this particular software is not available to non-Cochrane reviewers, unfortunately. Classifiers are really, really useful for cutting down the total.
I think Terminal is not only for...
The one limitation with the classifiers is, though, they do have limited applications. There are sensitivity issues with this approach. So it, as I say, only works well on those very well-defined, well-characterized criteria. So there's only so many things you can apply these classifiers to. Okay, so that's screening. Next, we're going to move on to the data extraction phase and the quality assessment phase of your systematic review. So data extraction is all about pulling out the relevant information from those included articles. Most of the SR tools I showed you previously, they don't have a lot of AI features inbuilt, although they do have very good templates for organizing the data into. Thankfully, we still have our LLMs, our ChatGPTs, our Claudes, etc., that can help us with data extraction. So how good are these tools? People have started evaluating. We've got a couple of very recent papers here from 2024. They tested on small batches of papers, but multiple different items. And the accuracy is pretty good, 68 to 96% accurate when they've used these tools to do data extraction. So that's quite promising. Caveats to these studies, as you can see, their sample size is quite small. So maybe they've not covered every single study design. Maybe there's some data items that work better or worse with these particular tools. And because it's quite a small sample, definitely there's going to be underreporting of false positives. So that's something to bear in mind. Is it hallucinating, making up data? So you can't entirely replace humans, but maybe we can use these as a first cut on your data extraction. You can use an LLM to do the initial data extraction and then a person to do the cross-checking. So it can save manpower. If you do want to use that as an approach, there's a couple of tips just to share to make that as accurate as possible. When you're prompting your LLM, you should make sure you assign it a role and tell it it's an expert in systematic reviews. You then need to tell it what its task is. So here we're looking to extract specific data items from our papers. And then you need to tell it each and every single item that you want it to extract, and you need to define each and every item so it's able to locate them within your articles. And then fourth, most important, test and refine. Definitely you're not going to get it right in the first cut, so keep iterating until you've got it to a level that you're happy with. Another possible way to improve the accuracy is to push the data extraction through 2 different AI tools, and then you can get them to compare and debate disagreements. So that's another little tip just to get, increase that accuracy in terms of using AI to do the data extraction. But ultimately, again, we're not entirely replacing humans. We still need that personal touch just to check at the end. So we've used LLMs to extract our data. Can we now use them to assess the quality of the articles? Quality assessment in systematic reviews is all about looking at bias in the studies. That helps us interpret our findings. And there are many, many different quality assessment tools out there. So just listed a few. There's many, many more. And there have been some studies, again, fairly recent, 2024, that have looked at whether LLMs can also assess the quality of the articles for us. The success rate is not so positive. When they looked at overall risk of bias between human and a ChatGPT, there was 61% agreement. And then this paper here concluded with a rather damning statement saying using LLMs as an assisting technology for assessing ROB2s, that's one of our quality assessment tools, currently seems beyond their reach. So not so positive on the quality assessment side of things, but hopefully with time, this improves. Aside from LLMs, thinking about those tools, those software that I keep referencing back to, they do have some semi-automation features inbuilt into them. So a lot of them will use NLP to help highlight key sections of text within your article, and that can help a little bit in your decisions on the quality assessment. You don't have to read for the entire article. It will flag up the sections it thinks are important for you to make that quality assessment. One issue the tools do tend to face is when there are multiple articles for one study. So that is one limitation with them, but there are some features in the software as well, these other software tools to help with quality assessment. Okay, so just to recap on those 4 steps that we've covered. So I would say, based on what I've shown you, AI is definitely a helpful assist. It's not going to entirely replace humans doing systematic reviews. So do be wary when you see tools that are claiming to be able to do a whole systematic review for you. They're just not there yet. It's quite obvious from the data. The hybrid approach seems to be where things are currently at. You can use these tools to assist you. To get the most from them, it's still important to have some domain expertise, whether that be in the methodology, methodology in terms of creating your search strategy and knowledge of syntax, or whether that topic's specific. But it's important, again, have that domain expertise to know what you're looking at, to be critical of the output that's being generated from these from this technology. Okay, and then I just want to wrap up the talk by sharing some other resources that might be useful to you all on your AI journey. So there's some organizations that are very interested in trying to automate this process, so keep an eye out. This first group is a collaboration between several groups. They have a very useful toolbox on their website that lists all the different types of software that are available and the different features that each of these softwares have. So that's quite a nice resource. They also seem to run some workshops occasionally as well, so it might be useful. Prisma is coming out with some AI guidelines. They're not quite there yet. They do have a paper that outlines key things that you should report in your publication if you're using AI to support a systematic review. It's not a checklist like traditional Prisma checklist, but it's an outline. Hopefully guidelines are out soon, because this paper was published in 23. So hopefully the full checklist is with us soon. Cochrane has also launched its own methods group. So Cochrane very interested in AI as well. And their remit will be to refine practice, set guidelines for methods, etc. So definitely a group worth keeping an eye on as well. And then this final organization, RAISE, Responsible AI and Evidence Synthesis. So they've generated various guidelines on the use of AI in systematic reviews, one of which is on the role of AI in evidence synthesis, building and evaluating the tools, these AI tools, and then selecting the most appropriate AI tools. So this is also quite a useful resource if you're looking to use AI in your systematic review. Okay, and then that's the end of my talk.
Anyone has any questions for Jenny?
Jenny, great talk. So I'm curious, I think in very clear outline of where the benefit of AI could be used at different parts of the review. So I think in terms of search strategy, that seems to be the most obvious layer, and quality assessment is clearly not there yet based on the sort of review or paper that was shown. I think where the iffy part is with the extraction, and I think you gave some possibilities of its use. What's your stand in terms of how reliable that is, and also in terms of journal publication, how receptive are they if that's that screening part and extraction part, and what's your experience with it?
Yeah, I think what I've seen and what I've read for data extraction, you can use these LLMs to assist you, but you still need to have that cross verification by a human, by a person, because we can't entirely trust the output yet. I mean, the accuracy was quite high, 68 to 90+% is very promising, and data extraction is again another time-consuming step. So even if you could get rid of one data extractor, replace it with an LLM, and then just have one person cross-checking, I think that saves manpower, saves time. Yeah. In terms of publications, I think a lot of the journals are pushing for transparency. I think that's the key thing, that you're honest, transparent, clear where and how you've used AI in your research.
Yeah, so in the data analysis stage, when we're trying to sort out the information and assign it in different themes, What kind of AI tools would you recommend for that stage?
Data analysis. To be honest with you, I wouldn't have any recommendations just yet on that stage. So apologies, can't answer that.
Yeah. Because just thank you for your lecture. And I have listened that there are so many AIs in each systematic review. When we do the systematic review, so is there one AI just combine all the functions together? Because I think it's very hard to learn different AIs. Maybe I think compared with the learning different AIs, maybe for ourselves, I think it's more it is more saving time. By doing ourselves. So that's my opinion. Is there any possibility to combine all the functions together?
I mean, that would be the ideal state. I don't think there's one piece of software or tool that does it all. And it's going to come down to lots of different factors. So a lot of the software is showing you you have to pay for it, right? So it's going to come down to budget. The setups ever so slightly different between the different tools. So it will come down to personal preference as well in terms of what kind of style you like with the instruments. So there's not really anything that does it all. I think you have to kind of make your own decisions on what you feel you work with best and what your price point is.
So maybe will have a function. The AI have all of the function together. I think maybe I think for me I can accept to pay some money. Okay, thank you.
We have one question in chat.
Anyone else from the floor wants to ask anything? If not, we move on to the Zoom questions.
Yep.
Yeah, this is the first one, I think.
Okay, so we kind of touched on the first question at the end. So does not are looking into. There was a question right at the top. This one. Are there regulatory or publishing guidelines emerging around the use of AI in systematic reviews? So I think everyone's waiting on Prisma to launch their checklist, although we do have that publication that already kind of outlines what you should be reporting in your manuscripts that we can make reference to. So
Jenny, can I ask a question, please?
okay.
Thank you very much for the presentation. It's been at the introductory level has been most illuminating. I think that what becomes clear is that there isn't a single, let's say, resource that will be able to that we can deploy across the whole process. However, I perceive that elicit, for instance, seems to be useful for a number of steps. I wonder whether you may have any experience of use with it, and it may well not be the case. So that's the first one. Or when I say elicit, with any other that you think can be used, can have a more comprehensive approach. And the other one perhaps is also if there is an opportunity also to keep an eye on more recent Cochrane reviews, because they will be reporting most likely on the use of such tools. And considering that Cochrane is very resource intensive and the gold standard for systematic reviews, it may be also useful perhaps for ensuring that we're up to date in terms of what is going to become, I presume, the gold standard of practice, which is some level of AI enhancement.
Yeah. So as to your first point, as I was sharing earlier, I don't think there's one particular tool that I would recommend. I guess I'm more familiar with Covidence and Elicit as instruments, but even those for instance, don't have the data extraction features inbuilt yet, although I believe a lot of these softwares are trying to get there. So maybe in time, they'll have more functionality, more options inbuilt into them. And definitely your point about watching Cochrane. I mean, they are the leaders in systematic reviews. They have a work group interested in AI application in systematic reviews. They're already developing software that uses AI to support that review process. So definitely they're the sort of principal group to keep an eye on in terms of AI integration into systematic reviews. Okay.
Do we have any more questions in the room?
There's two in chat.
There's two in the chat.
Yeah.
Sure.
Okay, so next question. For screening, we usually use two researchers. One researcher, can one researcher be replaced by AI? Is that acceptable by journals? I think from what I've shared earlier, probably the technology is not quite there to replace a researcher per se. The AI is more assisting with that screening process. So one of the examples I gave was it flagging up chunks of text that might be relevant to your screening decisions. Maybe it's AI that's ordering your articles into most likely to be included to most likely to be excluded. So it's more at assisting level, I would say, than replacing level. Okay. I've not, I mean, there's a lot of articles that discuss how different tools can be applied at different steps of the process. I can't share an article off the top of my head where they've done a purely SR with AI versus humans. I know some of these tools that I've showed you do claim to be able to replace humans entirely. I think Elicit has this claim on its website. You can use Elicit to do systematic reviews, but you know, some of these evaluations that I've showed you, there do seem to be limitations. So I'm a little bit skeptical about these claims. Yeah, so definitely I think there's an issue in terms of, can we trust the results of AI? Yeah, I mean, to be able to extract data, you're going to need to have access to the manuscript. So whether that's you paying for it, you having library access, you're still going to have a PDF copy of that article to be able to push it into the software. Yeah, this is a limitation with LLMs. There is inconsistency in the process. I would say it's very important that when you're using prompts and LLMs that you prime them right. So one of the pointers I was saying earlier, you need to tell LLM it's an expert in a particular topic. You need to be very specific about the task you want it to do, to define it really well, very clearly, and be critical of the output it's generating. Maybe you need to tweak your phrasing slightly, your wording slightly. So you need to take that time to refine, review, and do it again until you get to an optimal level. But there's not a lot we can do about reproducibility. It is a limitation of LLMs, unfortunately. Okay, so is there a time in the future when you feel hybrid approach becomes standard or recommended approach for systematic reviews? I personally feel that we're already getting to that place, certainly in certain steps, like data extraction could be one area. Developing your search strategy seems to be a very promising area as well with some of these tools. So I think we're almost there really in terms of using AI as a hybrid approach in conducting systematic reviews. But certainly we need to be adhering to the standards and guidelines like PRISMA, Cochrane recommendations. Okay.
Anyone else has any other questions? If not, then thank you so much for attending our talk. Thank you.
Thank you. And also, thank you for attending this webinar of the Center for Research seminar. Sorry, it's because I'm joining online. Center for Research in Health Systems Performance. We have a series of seminars in which we want to showcase latest developments in methods for research, but also in terms of some more substantive outputs as well, I mean, of research projects. The next one will be in relation to some developments for policy in the UK, and it will be presented by Michael Anderson, who is a lecturer at the University of Manchester, visiting with our centre and also with experience at the London School of Economics. And details will be shared shortly. And in the meantime, please join me in thanking Jenny for this fantastic overview and for her presentation. Thank you. Thank you and goodbye.